Hi, welcome to this Open Security Summit session in June 2023, and we have another, great exploration on security katas, and this is the second session on this topic that we have here. And Luis is going to walk us through a more in-depth analysis of this great technique and this great practice, which is, actually brings a lot of science to this process. So, Luis, over to you.
Thank you very much. So we're gonna continue the threat modeling kata we did last time. So I am a security architect, platform security lead in my current role. I have been doing threat modeling of many different things since the early 2010s. Airplane systems, IT systems, OT systems, automotive systems, some IoT got in the way. These are my social media. And let's get started. So I know there are plenty of definitions of threat modeling. My favorite one is the one from Brooke Schoenfield. Threat modeling is a technique to identify the attacks the system must resist and the defenses that will bring the system to a desired defensive state, which informs us why we're doing threat modeling, right? We want our system to resist the level of attack for which we design it. And that is based on the criticality of the system and the value of the data that we're processing. Now, threat modeling, regardless of which methodology you take, I think the whole world has settled down into this 4-step model, which is understand the system, model it, analyze what could go wrong, identify and document vulnerabilities and threat scenarios, do mitigation analysis, or risk and treatment, if you prefer to call it that way, and then validate the outcome. Make sure that you analyze the right resources and didn't start too late, or didn't do too much or too little. Kata is a word that comes from the Japanese. There are 2 different kanjis, symbols for that. I don't really know enough to tell the difference between either, but I chose this one. And it means form. So if you know the word kata from martial arts, it means basically choreographing your movements to make them be fluid and make them flow when you need them. And it is practiced to memorize or to create muscle memory. In that sense, many years ago, Dave Thomas was visiting his son during karate practice, saw what a kata was, and he said, hey, we know we should be doing this for coding. Ted Neward took it further and said, okay, let's do software architectural katas. And there's a repository with katas in GitHub, and there's a website where you can look at them. And basically, I'm extending that idea, taking it further and saying, okay, let's take one of these architectural katas, let's figure out what could go wrong, and then get started with it. So to set up your environment, give me just a second to make my screen a little bit smaller so that I can see you in the center. So to set up your environment, you need, I am working with VS Code. I am working with the GraphViz plugin. And in this repository, github.com/lf servin/oss-threat modeling, you will find a file that you can import directly into your VS Code. So if you open VS Code and you open the OSS threat modeling repository directory, you will see a .json file. This .json file, you need to put it in preferences, user snippets, choose dot, and you should paste it in here. So replace the existing file and paste yours. That will be all you need to be able to follow this example as it is. So give me a second. All right, so that's basically all you have to do. And the plugin I am using is that one here. From, I don't know, I have 2 plugins installed. You can choose to install them both as well, from Evans and from Joao Pinto. These are good places to start so that you can follow along. Now, as to the threat modeling part. So the first step is modeling. Perhaps you have seen threat modeling diagrams done with a threat modeling tool. So data flow diagrams created with a threat modeling tool from Microsoft. I don't love creating my threat models with a threat modeling tool because sometimes the level of detail is not clear. Sometimes there's too much detail, sometimes there's too little detail, and the tool is incredibly verbose. So you can have hundreds of potential findings that you need to validate, and it's incredibly noisy. So I would suggest not to get too deep into that. I rather use a more structured approach from system architecture. I like the model, the diagramming model from Simon Brown. It's called C4 model because every layer starts with a C. Context, the system and its users and the third-party systems. Container, component, and code. Containers are deployable units, not Docker containers. And the most important thing, and this is where the threat modeling tool fails horribly, is that everything has to be labeled. You labeled your data flows, you labeled your elements, and you are consistent in the usage of colors. For example, blue for in scope, gray for out of scope, and you tell what every element is there for, both the nodes and the edges. So meaning the lines connecting the nodes. Once that is done, basically you can imagine it as being some sort of Google Maps where you can zoom in. So you have your system, your target of evaluation in context of its users. You zoom in, see the deployable units that make up the system. You zoom in to one of them. You see the code libraries or whatever you have, and then you can zoom into one and you can see individual functions. I hardly ever have come so far down, except when I ask for a demonstration of a particular way of an implementation of, for example, authentication, authorization. So there's this is the system. We're gonna do the analysis. Someone rang the door. I need to open the door for a second. I'm extremely sorry. I'll be back in 30 seconds. But in the meantime, you can look at the system requirements.
Yep, no worries. I'll pause the recording. Meanwhile, I'm also
thank you.
listening.
Sorry. All right. So back from a very short break. So again, this will be in the show notes and in the slides. This is the repo where you can find the exercise and the diagrams. And this is our target of analysis. So our target of analysis is a SaaS solution that supports grading systems. So statewide grading systems in one of the states of the United States. But I mean, there's nothing saying we couldn't do this in other states or in other countries. I know Germany has the same kind of, because I live in Germany, I know it has the same kind of nationwide tests that every student has to go through when they want to graduate from high school. So that could be a system that we could sell overseas. So if we're flexible towards the future, we could add these requirements. And the idea is that students will only be used the application in testing centers, and most of these will be schools, but not all. Students are able to take the test, and the results are consolidated into a single location, representing all of the test scores across the state, by school, by teacher, by student. Tests will be multiple choice, short answer, and essay. So we have 3 types of answers or tests. Well, test will have different types of questions, and the questions will be either multiple choice, short answer, and essay. So I suppose for math, you might have multiple choice, whereas for literature or language, of choice, it will be an essay or a short answer. There would be some reporting to know which students took the tests and the scores they received. So I suppose that is especially useful for the directors of every school or the teachers. Short answers and essay questions will be graded by teachers, and they will add the essay grades to the system. And last but not least, any changes involve 3 governmental agencies to make sure that the data is secure. The state does not own the hosting center. Everything is outsourced, and every project, the project must fight for its budget every year. So without further ado, we can start. Any questions as to the use case?
No, cool. Nice to meet you, Juan.
All right. So we started doing this last session. And this is what we had. So our target of evaluation is a software as a service solution. And of course, these are all the details that we decided. And we came out with this diagram. So let me show the diagram again, and then we can start working on the next version of the diagram. So I create the diagram, make it small. Now there it is. So
do you need to do something to open it in GraphViz, or should you open directly?
you might need to have GraphViz installed. So I'm working on
I think I might need to do that. If you go to your terminal, if you run dot, will
yes.
will it give you?
It gives me an answer, yes. If I go to the terminal and I write dot, it's dot -h, it tells me something, right?
Got it. Yeah, I think I need that.
So you have to have dot installed. That's the last requirement. Of course. Sorry for that. So based on what we just read, so we have testing centers, which could be schools. We have testing centers, which are not schools. So different network zones, different scenarios, different threat actors. We have students in both. We have teachers. We have a grading system, and this is our target of evaluation. The grading system
assigned IDs to these things. So, for example, in a lot of stuff in my world, we end up in Jira, but it could be something else. But I think, you know, there's a need to connect these to other systems, right? To wider things. Like if you have an ID, you would put it here, correct?
Of course. Now the question is, do you have an ID for the environment it should be running or for the user, right? Because in this case, it could be both the same user, but one year the same user does it in his high school, and the other year the high school is not lending the lab and they have to go to a testing center.
No. I meant almost the ID for the node. See what you have here, when I look at this, these are nodes, right? You got a node represents the student, the PC in a computer, PC, you know, in unprotected, and then the teacher, and even the grading system. All of those are, if you think about nodes of actually a wider graph. And part of my thinking here is eventually to start to create these programmatically using a graph database, because at the moment the data for this is in your
in the diagram.
In the diagram, correct?
Yes.
Yeah, where I think in the medium term we almost want this diagram to be created almost from a graph. Do you know what I mean? Exactly.
So yes, you could add that. I'm not exactly sure where to put it. So it could be some metadata for the node. Yeah, so it will be metadata. You will be one of those, you know. I'm not sure how much metadata is supported in the GraphViz format, to be honest. I haven't tried that. So that's something we definitely could try. Cool. So basically what I'm doing when I create a node, I'll make the diagram a bit smaller, is make it a bit prettier than it usually is by default. So I create a node that has no shape. So all the shapes are plain text so that I can do some HTML inside. So I'm basically creating a table, an HTML table that has images. And it's, I mean, if I turn the table on, that the cell borders to 1, so you could see here how the table
Yeah.
looks like.
Cool.
So
Yeah, that
that's,
makes it much easier to read, isn't it?
and the advantage this has to Draw.io and other formats is you're actually able to see in the commit message or in the commit or in the diff, git diff, what changed in the diagram.
Yeah.
Draw.io, it's fantastic. You can also have the plugin here. Now the problem is all visual and it's all a bunch of XML in the background and it's so huge, there's no way to know what changed exactly.
But
And
that's why we almost want another level of abstraction, isn't it? Where you can start to almost just diff the behavior, right? Almost the content, and then have a way to create some of these. So even that table is powerful, but you know, I wouldn't need to see the diff. It's just, and I guess you're saying that if you're only making a couple of changes on the content, that's what you see on the diff in GitHub.
yes, exactly. So if I change the description, if I change a connection between nodes here in the relationship,
that's where it gets really powerful. Correct.
That's incredibly powerful, and I can just replicate this to do the component diagram, right? So we have the context diagram. Based on the context diagram, we created a list of findings last time when we were discussing this.
Yeah.
So we have spoofing, take an exam on behalf of someone else, selling the question. So we had the taking pictures of the questions for selling, for cheating, for memorizing the questions, attending different locations for the exam, repudiation. I wasn't there, tell me that I was. Those are not my answers. So how do you make sure that there's no repudiation on the answers, on the content? Spoofing, get the teacher access to the system and grade myself. So if teachers are grading answers, there are competing interests here to get access to the system. So these are all things that students could be trying out.
Isn't it amazing how fast things have moved that now we should add one, which is ChatGPT take the exam on behalf of the student, isn't it?
Of course, I mean, we could add that one here and basically is, well, not selling the questions, but basically cheating, right? So cheating couldn't be classical. So
But
here
then,
we will
and you
have,
could even add an interesting thread, which is how to do that without being detected. Do you know what I mean? So, and that's going to be an interesting thing. It's a bit like, you know, if you are a student that has 56% out of 100, if you then get an exam submitted that, or you get 99 or 98, you almost need now a cheat that actually almost gives you your score. Do you know what I mean?
exactly. So I just added that one to the why is it not taking the, so what did I do wrong? Cheating. Why is it not taking?
You might need an enter above.
Okay, one more level. I don't know, something happened there with the levels.
Yeah.
Oh, it's the space. It had a space too many. No, it's
You might have a tab actually.
It's okay. Now it's working. So use ChatGPT to answer the question. So these are all threats that we have identified from the student side. So this is just a recap from last month, right? And the teachers, we were saying, okay, grade your own. There's an incentive. Teachers are graded with the students, right? So if my students do better than average, I get a better grade, thus opening positions for salary increases or something else. So if I know whose answer I'm grading, I might be more lenient than if I don't know who am I grading other students worse than necessary. I could also be making money on the side by selling the questions. I could facilitate cheating. So attending several locations or allowing someone to take the exam on behalf of someone else. And of course, directors also want to have better grades by leaking the answers. So we need to figure out how we're going to keep the findings safe from everyone. So this is what we came up last month. Now it's time to go further. So we have the admin. We don't yet know how the admin is getting in, but we know that the admin well, the school director, right? So we have a school director that adds teachers, adds students, gets reports per class per school. So someone has to manage who will have to take the exam, right? So we said that was the school director or someone on the direction side of the school.
By the way, just for reference, to get this UI that we're seeing here with Lewis, I had to go to the command palette and open the GraphVis open preview, and then that's the one that will then preview the what's it called?
Oh, did you?
That
Every time
window,
I have a GraphVis diagram, I have this open preview to the side activated.
There you go. That works too. Perfect. Yeah.
So that's a bit easier. For Wordly maps, they don't have it, so I do have to go and click on open view. But for dot, I usually just
Yeah, that worked too. Sorry,
click there.
I haven't used that. I have cool, brilliant. Yeah, I got it. I'm with you. So which one are you looking at the moment? You're looking at the great context on the root.
Yeah, I think we
Oh.
didn't add the admin. So basically, we could add the admin now and say, okay, the admin connects to the grading system.
Very cool. And by the way, this is crazy reference, from crowd watching, right? Like when you do this with an audience in a for example, threat modeling session on site or remote, it's super powerful to have it on screen and then literally be changing the code and seeing the diagram for everybody. It's very, very powerful.
To be honest, even if presential, I don't use the whiteboard that much anymore because I have to pass it in clean afterwards. So it's a lot of work to do it. It's
exactly.
2 times, right?
So you might as well be creating the diagram in the session, isn't it?
I do. So basically I share like the right hand side of so to more or less show you how I do it, I basically make it big and now move it to the side. So basically I show that side when I'm sharing the screen with someone and work on the other side. Of course, now I'm not doing it in that exact way because I want you to see how I change the code. But basically here we say, okay, logs in, does administrative functions. And that means we now have to open up the system and start looking at the system, right? So we already identified problems at this very high level. These are usually unhappy path scenarios that are not considered in the usual requirements. And this is the first place where you can start looking. So you don't even have to start doing strife at this layer. At this layer, it's just abuse cases. So what could go wrong? How can I use the functionality against the system? Now, Frank, Adam, do you see any other things on how you could abuse? So do you think it's different? A student taking the assessment in the testing center, which is not a school rather than the school, are there any difference we should consider? Raise your hands if you think of anything that we should consider. Doesn't seem so. Okay, so I mean, it depends a lot on who is proctoring the exam, right? Are the teachers who know the students proctoring the exam for their own students so they know and they can pass list? Or do we have people who don't know the students and students at a young age don't have IDs? So how do you make sure that whoever is taking the exam is actually who this person should be? I don't know, right? So if we're taking the test in not a school, and the teacher is not proctoring, I have no idea how they're identifying the students. So this is a lot more risky. So we could add here a threat actor. So we could add here a fake student. Let me see if I.
Yeah, because the student could, even somebody could be there doing it for them, isn't it?
Yeah, so here we could add a fake student. So so the short form I use is HTML, and I will call it bad student. Bad student. So if you tap through the snippet that is created, you will jump immediately to the corresponding spaces. So I jumped from the name of the node to the label of the node, bad student.
That's interesting. What creates that? You got a
The
snippet
snippet that I shared, remember .json, the one you copy pasted?
Yeah.
If you type HTML and you tap through the fields, it helps you jump from one to the other.
Cool.
So I jump to the file path. I have one in dot images hacker transparent PNG. No, I don't didn't name it that way. Give me a second. Terminal. No, not the hackathon, sorry. Hacker minus transparent. Okay, sorry for that, my mistake. Hacker minus transparent. So here you can see I just added within the picture without a lot of trouble, a nice looking hacker. So the bad student. So this is someone pretending to be a student, and the purpose is cheater paid for the student to pass the exam. So the only thing with it being HTML is that you cannot really add break lines. So I had to add the break line like in HTML to pass the exam on their behalf.
And this is fundamentally plan to ML, right? So basically behind under the hood, if I'm not wrong. Graphviz. So Graphviz uses this to render it. So Graphviz has some support for HTML.
Yes, this is native Graphviz. So this is just the reason this works is because the node type is plain text, and it just fills in within the everything. So I control every aspect of this node. So this is also part of the snippets I created and I shared. It's just start typing, I think, diagram or dgraph, and it just fills it out for you.
Yeah, very cool.
So, but student cheater paid for the student to pass the exam on their behalf. And the nice thing about this is that I can do the student out in a group. So student out and that student. So that easy it is to create new lines, right? So bad student and the student try to do this, pass the thing on the exam. So now we know who is doing. So
that's an interesting one. So because you put the brackets in there, is that why you create that box around it?
Yes. No, the box around them is because they're a cluster.
Oh, because I got it. Because you got the cluster, but that's
no, the box around them right now is. Can I make it bigger? No, the box around this, the curly brackets here is to make sure that they both have the same line.
Yeah, got it.
So now in this sense, I'm answer label. First of all, label, and then answer exam. So here we have the bad student answering the exam, and here we could have the student cheating and doing all the things. But I mean, in both cases, it is different, right? So here we have someone pretending to be someone else. So here we have the nice student, and here we have the bad student, the paid for, or whoever is the twin brother or the older brother or whoever, right? So we have the teacher, and now we could start looking at the architecture, right? So we could say, okay, if we open the grading system, what could we expect to find, right? And this is the point where we have to work with an architecture. So since this is an architectural kata, we don't have a given architecture, so we would have to create architecture. So this works great with developers or with system architects, because they could help you create this, and you can do threat modeling on the fly as they start creating the system. So basically we could copy. So let me save this file. Okay, it's saved. Now I'll just replicate the file. Copy. Paste. And I will rename it to container. Come on. Why is it not working? Come on. Come on. I have no idea why I cannot change the. Oh, I pasted it in the wrong place. Okay, I need to open the terminal, pardon. Create context. So move create context to create kata, create container graph base. So now here, what I can do is close this thing, I close this thing, I close this one. Now, of course, this is still the same one, but now I could start adding images. I could start adding AWS architectural elements, right? So one thing I could expect to see here is some sort of WAF, or well, first of all, a network, right? So I will start carving out here the network, and I will start pruning the number of students, right? Because we don't care too much about the students, we care about the connections in and where they are connecting to.
So in terms of grouping a bit together, would it be good to, for example, start creating folders for these scenarios? Do you know what I mean? And then inside those folders, you can almost have a markdown that explains what it is, and then all the diagrams that you create based on that particular scenario.
What I usually do, to be honest, is, give me a second, I have the report here. So I have the report. I start adding the diagrams and how I look at things. So this is the diagram. I represent whatever I start finding here, and then I start adding here the vulnerability, the attack scenario, and the outcome. So I have one document that encompasses this, and then I add to this document with a context diagram, the container diagram. So the detailed technical view of the cloud system in this case.
Cool.
So basically I could add here so here, of course, we don't yet have the grading system container diagram. Images. Well, it couldn't be great context, but rather great container, and I will just print out the grade context again. Give me 1 second because we made some changes. So context. So pardon me just for 1 second while I print the grade context with the changes. Thread modeling, images, grade context. Yes, override. And that basically overrides it in my diagram, so I don't have to suffer too much. And then I can start with the container diagram. And here I could start by deleting this grading system, because now we're going to go into the details of the grading system. So here we could say, okay, I have a cluster, and here we have a external zone, cluster external, and here we have the I don't know, let's call it DM set. This is the exposed. This is to the internet. So we can see that that has changed a bit. Actually, it's not yet there because we removed it. So it's an empty cluster right now. And here we could have different nodes. So I will not put images right now. I'll add the images later. So here we could have the test API. Test API. This is a, I don't know, let's say Python. Which framework do we like in Python for making APIs?
It's called Fast API.
Fast API, lovely.
Which is pretty
Fast
awesome.
API.
Because it also gives you the Swagger file.
I know. They're like different flavors, right? But then you can say that. And then this one is receives answers from authenticated users. Okay, let's see where we have it. So it should be, so we can see that it's growing here, disconnected from everything. But we can start seeing that here we have the test API. Now we have the test UI, which is hosted in a React or whatever. So let's say this is the test UI. No, HTML node, test UI, test UI.
And by the way, like what's cool about this is that what we're really doing is also defining those, what's it called, pressed boundaries, isn't it? Where you start to understand exactly, what's running where, and that will make a massive difference in our threads.
Exactly, that's the idea. So the idea here is that we have Node.js, that we understand, and that's why I like the C4 modeling convention, because you really understand in a very structured way who interacts with your system, how your system is distributed, technology choices, and then you can add on that whatever else you need to add on that. I mean, if we need to understand how the test API is built, the individual components that make up the test API, we can go so far, but we don't need to go so far to see what could go wrong in general.
Yep.
Right. So here we have the Node.js interface. Let me make this word wrap. It's a bit easier to work with word wrap. Oh God, I lost myself. Sorry. Node.js. Okay, we have a Node.js API, and this one basically shows the questions to the students. So now we call it DMZ, but I mean, this could all be running within a Kubernetes cluster, or this could be running whatever we wanted, right? So that's the testing part. Now we need the testing creation part, and we need a few more elements, right? So we have the teacher UI. Here we have it. So here we have another HTML node, teacher UI, teacher UI. And again, this is a Python fast API thingy, and this is allows teachers to submit questions. Further, it allows teachers to, I mean, we could save ourselves some trouble, pardon, allows teachers to break here. And then submit questions. Great. Answers. What else could the teachers do?
Well, you could also have a malicious teacher, right?
No, well, I mean the normal right now. I mean, like the normal requirements. Right now, we're just painting the happy path,
mapping the happy path.
architecture, and then we can start doing the hacking, the bad stuff, right? But first, we need to understand what we're dealing with. So students' test will be multiple choice. The system should have a reporting system to know which students have taken the test and what score they received. Short answer and essay questions will be manually graded by teachers who will then add essay grades to the system. Change approval, state does not own, project must defend its budget. So yeah, that seems fair.
And also, the other thing that's interesting about up until now is ideally this should be provided by the dev team. Do you think, isn't it? Ideally, this stuff should already.
To be honest, I usually create it with a dev team because I have yet to see a dev team that keeps their documents up to date, because they have to go to Visio, they have to go to Draw.io, they have to leave their ID.
But that's why the developers eventually start to love this kind of stuff, right? Because this allows them to keep maintaining their documentation up to date. And this is a good example of where we can add a lot of value to security teams, because we need this, and they also want it too.
Yes, exactly. So in one of my previous positions, I actually gave like a class on how to do this, and some teams actually started doing it. So I couldn't enforce it, but at least it won enough traction that people were willing to try it out, which for me is a win, right? Oh no, I got it wrong. So this is the Python fast API thing, and the UI is Node.js. Processes, input from users, from teachers. So now we could start looking at this and say, okay, well, actually not everyone will be talking to the same thing, right? So ideally, we could have students not talking to grading, but talking to what do they call it? And that's the only thing you need to keep in mind always, like, how did you call things? So we called it teacher API, teacher UI. Let's make it all look the same. So teacher API with small and API and big, teacher UI big, test UI, and test API. Okay, so with that naming convention in place, it's easier. So the student talks to the test UI to retrieve questions from. The student talks to the test API and And this is a crucial thing that is often overseen by developers, right? The UI being Node.js is loaded into my browser, which executes in my context. And the API is actually not necessary. It's optional. At the moment where it runs in my context, I can just decide to use it or not.
Yeah, but also you could argue that that test UI should not be inside that DMZ, right?
Well, you're going to serve it. So the static file.
Oh, that's the static version. Oh, got it. That's the static version of the test UI.
So basically, well, rather than retrieve the questions and send responses to, disappears from this one, right?
Well, I to be honest, I think there's value in actually putting it on the browser, because if you think about it, that's what you have then there. It's almost just static files, isn't it? If
it is, but you still have to identify that you have a Node.js or not a Node.js, Nginx probably, or CDN or something serving these files.
Yeah, but then isn't it better to put the test UI on the browser context, because it implies that the sort of the trust boundary, like you said, like we need to go, oh, how does he get the data? Because that is just almost a static, server to provide content, which is important because you might actually have a node backend, right? You might actually have, which in this case we actually saying we don't have, because you actually say you're using Python for it. So if I saw this, I was going, why are we using Node.js? Do you know what I mean? Because you go, but if I have a Python fast API, what is the actual Node.js actually doing that an Nginx can't do? Because that would increase the attack surface.
Yes. Well, I mean, to get here, you do need some authentication, right? And that this is the point where I don't know how to give so either every student comes to school with, or to the test day with their password or their identifier in the hand that they received during class, or there's no way to onboard them, right? So there's a cat in a sack that's not exactly clear how it got there.
Yeah, or they can be given a UID, right? Some token when they do the test.
You can give them something, but how do you give it to the student? I mean, think of 11-year-olds. They might or might not have a cell phone. They might or might not have a laptop.
Yeah.
So you need to give them a piece of paper that they can take to the exam on that day or receive on that day and use it to type in and identify themselves towards the system, right? So here at some point, retrieve static content from, and then we might need to even say, hey, this is the browser running the test UI. So now, because this is a computer, not a student, the browser is running the test UI, is sending answers to the test API, retrieving the static content from here. So now we identify the relationships.
Yeah. Got it. So in your case, the browser is the box above. Yeah, got it.
So this is the browser running the test UI. And now we need to figure out, how does the user authenticate, right? And that's not something that they gave us. So we might need to add for authentication, which is something I usually add after the protocol itself, HTTPS UUID for authentication. So it has this person has a UUID, and then we could enhance this in the context diagram saying how this person gets the authentication code. I don't know, right? So we could add that later. And basically the same story happens to the teacher. So the teacher does not log into the grading system, and the teacher talks to the teacher UI, logs in, retrieves static content, and this is HTTPS. And they do have a user ID plus password. or some other way to authenticate themselves, or they're single tenant, let's say, single tenant. So they need to use the same credentials they use for school, single tenant. Let's
Yeah.
make ourselves easy.
Yeah, no, that's fair enough, right? Which actually then when you go into the remote one, that might introduce a curveball because they might not have the same system. Isn't it?
Yeah. So give me a second while. Okay, there it goes. So label, and now the label is sends grades to questions. Retrieve static content. Oh, well, sends and receives. So sends grade. So queries questions from, sends grades to. So basically the API, the teacher uses it to query questions to and send grades to, and this is just for the long form and short form answers. So this is the teacher, and we can say here is grading grades long form answers in the browser. So little by little, you can see that the diagram starts to look differently. And we could even say, okay, could they even be in the same segment? I mean, to be honest, I couldn't have these things in the same segment. I would probably want to isolate one from the other. And then we could keep on doing this exercise. I mean, I'm running out of time now. So I'm just going to wrap it up, showing like the next logical step would be to add here another cluster database, DB zone, VPC database, HTML, DB, I don't know, what's the SQL database from AWS called? I always forget.
Aurora?
Aurora?
I believe so.
I don't know, it seems good enough. Aurora SQL database. Now we know what we're dealing with, and then who connects to it, right?
Yeah.
So on the one hand here, stores questions,
Yeah.
answers. Oh, sorry, it's too small. Stores questions, answers, creates. What else do we have here? Student data.
Yeah, maybe stats.
School districts, schools. What were you mentioning?
Stats, like statistics and
Yeah,
or activity data. Depends, right?
Statistics.
Yeah.
And then of course something has to connect to it because else it has no value, right?
Exactly. This reminds you of that joke of that teacher that was doing a pen test course and said, here's a page that has all your scores and you all failed. Your job by the end of the semester is to pass. So like you have to hack into the system and change your grade. If you do, you pass. So I thought that was such a cool way to say, here's your grade. At the moment, you're all failing.
That's great. Teacher API, they both read. No, they talk to the. Did I just call it database? I just called it database. Okay. So that's the only thing. When you do this, you have to keep the names of the nodes in your head. Database, and here we could add a label in which, I mean, this couldn't be all too uncommon, in which you say read, write, data to, and they connect as the, so it's I don't know, encrypted communication, whatever protocol the database speaks, but admin user. So I have found this so often, and it's always a great discussion. Why it's a bad idea to
need, right? Yeah, because you see that makes a big difference. Because what's interesting is that you have, for example, these different UIs here, and then you can ask the question, why should the test API has privileges to change stuff? Where you should be in a situation where even if the test API has a vulnerability, you shouldn't have the privileges to change stuff.
That's exactly what I end up in my discussions with developers. So I usually end up here with developers saying, okay, it's a terrible idea to have admin rights here. Oh, but we do this and we do that. Yes, but if by any chance, any one single occasion you miss something and I'm able to say drop tables, you lost the game.
Yeah.
And that sometimes they react to that and say, okay, you're right.
It's a good example of saying that makes a vulnerability in that test API 10 times more toxic than otherwise, because then you almost limit the damage that can be done.
Exactly. So give me just 1 second, because right now it makes no difference to have the bad student here. So I'm just gonna kill them. And we do need the admin, right? So we need the admin to be able to talk to the admin interface. So the teachers are doing some things and the admin is doing the same. So basically we would need to add the same again for admins, but we run out of time. So this is an exercise I'll do and commit to GitHub. I mean, I can commit to GitHub. Well, I will not do live. I'll commit to GitHub in a few minutes after the call. And we can wrap this up next week. Next Open Security Summit, in which we do compare these against threat modeling tools from Microsoft to see who gets more actionable results, for example.
Yeah, and I think it'd be really cool to see if you can refactor a little bit, for example, that HTML code, so that you don't have the complexity and you have a better diff, isn't it, on the actual code. But the super powerful thing is at the bottom of that file that you have there, where the relationships are now easy to read, easy to map, easy to like, if you scroll down on the left, I think the real powerful is this bit here, right? In fact, if you just maximize that, like, that's the power, isn't it? And I usually try to just a little thing. What I tend to do here is just move it a bit to the right again. I tend to add spaces because I think you can. So I try to align, for example, even the arrows, so that they're all, you can almost read them. So you can add spacing. So you can add also, it doesn't affect the result. So you kind of get them all in one line, so you can see that at the moment you almost want to have all the arrows to the right aligned. Yeah, but you see, even on a student, I would also align that with the one below. Do you know what I mean? No. Go up to line 96. On line 96, the arrow. You actually, if you tab it, tab to the left. Yeah. Now, if you tab it and you align it with the arrow on line 98.
Oh, I see what you're saying.
Yeah. See, so by doing that. And then you might be that you might sometimes even allow.
I'm just killing this one anyways, remember?
Yeah, or maybe if you kill that, then you maybe don't need that. But you see what I mean? So I try to align it because from a reading point of view,
easier to read.
It's much easier to read, right? It's kind of like you almost go A, B, A, B, A, B. And yeah, so I try to align that in code. And yeah, you might not need such a big space now that you don't have the one below, but always add a little bit like that, a couple of extra spaces. And in this case, it's cool because GraphViz doesn't matter how many spaces you got. It still basically uses the separator in fact, even you could see even to the right of the arrow, just add a couple of spaces, it becomes already much more readable, right? So even there, yeah, just 2 spaces there, see? Or a tab, see what I mean? Like even that is already much cool, to read. See what I mean? Like it's
I
already
know what you mean.
nice.
So here I could basically add admin UI
Yep.
and admin API. Yeah, that's about it. I mean, the problem is once you cluster them, it gets really, you lose a lot of space, right? So either you don't cluster or you
Yeah, and
you
that to be
break the
honest,
line. I'm not sure if you can break the line, actually. I'm not sure if you
yeah,
can.
but you see, this is a good example of sometimes I prefer the inefficiency of not clustering because it improves readability.
Yeah.
Do you know what I mean? So sometimes it's like you might get a little bit of efficiency, but especially in the code, I always them goes, well, it's not because you can improve it or make it smaller that it actually makes it more readable. Because I think the readability is a lot more important than sometimes some of these clusters or some of these code optimizations that you have there.
Yeah, I
I
see
mean,
what.
because even here, what you can do is you can start to group them. Look at how nice it is to have all the admins in one place, all the students in one place.
Yeah, I think it improves readability a lot.
Absolutely, and especially once you start diffing it, it gets even more relevant.
Certainly.
I'm literally sending that screenshot to my team right now. Hey, check this out. This is threat modeling as code.
Well, it's diagramming as code, right? Threat
Yeah,
modeling comes afterwards. It's just this is the problem is this is not even threat modeling, right? This is the basis for threat modeling. And once you have this in place here, then you can start doing threat modeling because it's trivial now. You have all the information you want. You don't have to consolidate or correlate diagrams with descriptions and this other thing and this other that. Everything is one place. Now it's very easy to focus and just zoom in and you're done.
Yep. And then there's so much potential here, man. I really, this is definitely something we need to keep experimenting on this. And this is also an area where I feel, again, the new ChatGPT world of a code pilot and things like that. I think now we're getting to the point where some of these will be created programmatically, so we can take it to the next level in a much more scalable way. But this pattern will always going to be needed. It's just a way to scale this to a next level.
Certainly. I mean, this is the problem is I haven't found something that's really a lot better than this. So I know this is a bit clunky and it's not yet perfect, but the simplicity of GraphViz is by far superior to me, especially when diffing to Draw.io or other things that are more WYSIWYG. What you see is what you get.
So what I've done is, in some cases, I'll have a graph. I start to just graph, store those nodes and edges, sometimes in Jira, sometimes in JSON files, and then create the graph, right? Like that, using Plan2ML, which basically creates is GraphViz, right? It's just a wrapper around GraphViz. But to try to make it easy to understand and to visualize it. And I was work on a system that we were already creating those texts programmatically from reality. Do you know what I mean? So imagine a world where you analyze a code base or a repo, and those relationships that you have there, literally that text is also created programmatically, added to a version control. So you still have the same base, because it's like you mentioned before, Draw.io, Visio, it's all nice, but it creates works of art. People can't maintain it. And more we need things that come directly from reality. So cool.
Exactly. That's usually the problem I face. They spend so much time doing one thing, and then something changes. They don't want to do it again.
Absolutely, right. And also the worst part for me is that everybody becomes allergic to change, because in their heads they're like, oh, that's going to take me half an hour to do. So they almost start arguing why not to change versus just saying, no, that's reality. That's how it goes. That's how it evolves. And then, and of course you can version control it. There's lots of things that are not very good with it.
Certainly. So basically I have now made the diagram. So of course it looks a lot different, and we could prettify this a little bit, in which we make invisible connections between the UI and the API, so that it's less wide. But usually screens are wider than they're taller, so I rather have them growing sideways than growing this lengthwise.
Well, man, brilliant. That's another session, good materials. And then, for anybody watching, right, this is real world, right? This is literally how, at the moment we do stuff, and still the state of the art is, there's lots of great areas for innovating here. So cool. So Luis, thanks for doing this session, and I see you in the next one.
See you next time. Thanks.